Have you ever had that specific kind of gardener heartbreak? You know the one. You pour all your time and energy and care into a fruit tree, and it gives you absolutely nothing back. So what's really going on there? Well, the answer might be one of nature's most fascinating and kind of hidden rules, and we're going to uncover it together.
I mean, picture this, because it's a story that's all too common for growers in warmer places like, say, Florida or northern Thailand. You do everything by the book. The right soil, the perfect amount of water, plenty of sunlight, and the tree looks fantastic. It grows tall, it's leafy, a perfect picture of health. But then, year after year, nothing. No apples, no peaches, no cherries. It's maddening. You start to think, is it my fertilizer? Is it a lack of bees? But it's not any of that. The problem is something much, much deeper. It's happening at a biological level that we can't even see. So what is really going on?
That's right, your tree literally can't sleep. And you know, just like for us, a lack of proper rest for a tree can have some serious, and in this case, fruitless consequences. This whole idea of tree insomnia, well, it's the key to unlocking this entire mystery.
Okay, so to really get our heads around this, we need to talk about a tree's winter sleep. And that means we have to understand a critical concept in plant science called chill hours. So let's break down exactly what that means.
So what in the world is a chill hour? Well, think of it like a unit of sleep for a tree. For every single hour an apple or a pear tree spends in this cool but not freezing temperature zone, it banks one chill hour. This whole process is actually an ancient survival strategy called dormancy. The tree basically goes to sleep for the winter to protect its delicate future flowers from a deadly freeze.
But how does the tree know when winter is really over? I mean, it can't risk waking up on a surprisingly warm day in January only to get slammed by a frost in February, right? That would be a disaster. That's where this internal chemical alarm clock comes in. It's counting those cold hours, and only when it reaches a very specific, genetically programmed number will it finally say, okay, winter is truly done. It's safe to bloom now.
And what's so fascinating is how specific this temperature range is. It has to be just right, like a real Goldilocks situation. If it's below freezing, well, the tree's just trying to survive. It's not counting any hours. If it's too warm, say above 7 Celsius or 45 Fahrenheit, it's not really resting, so it's not counting either. It has to be in that perfect cool zone to accumulate those precious hours of sleep.
So what happens when that chemical alarm clock just never goes off? What are the real, visible consequences for a tree that simply can't get enough sleep? Well, let me tell you, the results, they are not pretty.
The official scientific term for this tree insomnia is delayed foliation. But honestly, I love the name sleepy tree syndrome because it just captures the idea so perfectly. The tree is basically stuck in this state of permanent grogginess because it never got the final signal that winter is over.
And the symptoms are just devastating. First, and this is the one you'll notice right away, the flower buds just give up. They dry out and literally drop to the ground. Then you see this really bizarre, uneven growth where maybe one branch leaves out in March, but another one waits until May. The whole tree just isn't waking up together. And ultimately, this constant stress from a totally broken hormonal cycle weakens the tree until, sadly, it eventually died.
For the longest time, this just meant that you couldn't grow apples in the tropics. End of story. But this is where science comes in with a totally brilliant solution. Plant breeders have worked absolute miracles to help these little insomniac trees. And the difference is staggering. I mean, look at this. A classic red delicious apple, right? It needs over 800 hours of chill. That's a full-on, proper cold winter. But breeders have developed these low-chill varieties, like the Anna apple, which only needs about 250 hours. And then there's the Dorset Golden, which needs less than 100. That's not just a small tweak. That's a massive genetic difference. And here are some actual examples for you. You've got the Anna and Dorset Golden apples we just talked about, and even peaches like the Tropic Beauty that have all been specifically bred to thrive in places that might only get a handful of cool nights a year. This is the key that unlocked temperate fruit farming for entirely new parts of the world. It's a game changer. Okay, so this is all great information, but how do you actually use it? This brings us to the action plan. How do you make absolutely sure that you match the right tree to your specific backyard or your farm?
It all boils down to a beautifully simple two-step process. First, you've got to know your zone. Do a little bit of research online and find out the average number of chill hours your specific town or region gets each year. Then second, and this is the absolute crucial part, only buy trees that require that number of hours or less. Don't try to push it, it won't work.
So you can kind of think of the whole world in different chill zones. High chill zones, those are places like Northern Europe or Japan. Low chill zones are places like Florida or the mountains of northern Thailand. And then of course you have true tropical zones that get almost no chill at all. The first step is just to figure out where you fit.
Now, for all you determined growers out there in those really, really warm tropical zones, there is a fascinating pro tip. So, since the cold weather is what normally triggers leaves to fall, some farmers will actually go out and strip the leaves off their trees by hand right at the start of the coolest season. This shock effectively tricks the tree into thinking, whoa, winter is here, and it forces it into a short dormancy. Pretty clever, huh?
So what's the big takeaway here? The crucial point is this: you just cannot fight genetics. No amount of fertilizer or loving care is going to make a high chill tree produce fruit in a low chill climate. Real success, it starts before you even put the shovel in the ground. It begins with selecting the right plant for the right place.
And that really brings us to the heart of the matter. This isn't about finding clever ways to cheat biology. It's about understanding biology and then choosing to work in harmony with it. And when you do that, nature does most of the heavy lifting for you. And that leaves us with one final thought. You know, chill hours are just one of nature's hidden operating rules. It really makes you wonder, doesn't it? What other invisible forces, what other secret handshakes between a plant and its environment are at play right now determining what thrives and what fails in our own backyards?